Hi there, in the last video we built this very simple HTMX driven table here where we can dynamically load more data from our backend, which is a FastAPI application. Now at the moment this is quite a dumb application because we're using a hard-coded list of film objects within our FastAPI function. What we want to do now is add a database to this application. We're going to add a SQLite database and we're going to set that up using the SQLAlchemy ORM in Python, and we're going to be able to get this data from the database rather than hard coding it. So let's dive in and we'll see how this can be done. Now we're going to reference a particular page in the FastAPI documentation, and it's this page here about relational databases. Now as it says, we don't need to use a database if we don't want to, but we can, and we can use any supported database such as Postgres, MySQL, Oracle and SQL Server, but we're going to use SQLite because it's very simple to set up. It's actually just a file on your file system, and Python also has integrated support for SQLite, so we don't need to install any drivers. We're just going to use that in this tutorial. So this is the page and it contains all the code you need to set up a database. We're going to work through that in this tutorial. Now if we go back to the project, now there are a couple of changes from the last video. I have embedded all the code within a SQL app directory. So within that we have our templates directory containing the HTML templates, and we also have a main.py file with our FastAPI function. As you can see here, it's called movie list. You should follow this structure in your own application and make sure you change the directory referenced when you're setting up your templates to SQLapp/templates. Now what you want to do to begin with is we want to install SQLAlchemy. And if we go to the SQLAlchemy documentation, you see that it's a Python SQL toolkit and an object relational mapper that gives app developers the full power and flexibility of SQL. So we're going to use that here, and it's very commonly used with FastAPI when you're integrating relational database applications. And we can install SQLAlchemy with pip. So if we stop the server that's running at the moment and we say pip install SQLAlchemy, then that will install that onto your environment and you'll be able then to use the package. So now we're going to get started with this tutorial. We're going to create a couple of files within the SQL app directory. I've already created an init.py, but we're also going to create a couple of extra files here, and the first one's going to be database.py, and this is going to contain our SQLAlchemy setup code. So let's start with this one, and we're going to grab some code from the FastAPI documentation. So let's go back to this page here. Now there's a right hand sidebar here, and one of the headers, it says create the SQLAlchemy parts. If you click that, we can basically just copy this code into our database.py, and we'll walk through what this is doing now. So first of all, we set up a SQLAlchemy database URL, and that points to our SQLite file that's going to be our database file. Then we use that SQLAlchemy database URL as the first argument to the SQLAlchemy create engine function. When you create the engine, you point it to the database file, and we have some extra keyword arguments here which we don't need to worry about. And we also have a session maker. Now this is what creates a database session. We bind that session to the engine that we've created in line 8, and that is stored in a session local class. Now we can instantiate that class in our FastAPI endpoints when we want to create a database session. And finally we have a base class that's retrieved by calling 𝗬𝗏𝗽𝗶𝗹. This is going to be used when we create a model to represent the film objects that we've got here in the films list. The films list has two fields, name and director. We're soon going to create a model that represents that, and SQLAlchemy allows you to do that. The models will inherit from this base. So we can save this file now and go back to the documentation. And on the sidebar here, we also have a section for creating the database models. And by the way, if you're interested in what each of these lines does, FastAPI has fantastic documentation where they are walking through what each line is doing and what it represents. So you can check this out if you want more information. For now, we are going to create a model. So what we're going to do is copy one of these models that's defined in the documentation, and then we'll adapt that to our film class. So let's create a new file called models.py. And in there for now I'll paste this code, and we can get rid of the relationship because we're not going to be using any foreign keys in this particular application. So remove that from your model, and we're also going to remove this boolean column here, and we'll get rid of that import as well at the top. So as you can see, we're importing this base class from our database.py file. This module here, when we call declarative base, we get a base object which we're then importing into the models, and the model class inherits from this base. and we're going to change the name of this model to film, and we're also going to change the table name from users to films as well. So the table that will actually be created in the database will be called films. Now we're going to keep this ID column because we need a primary key for our table, and that's going to be an integer field. You can specify that this column is the primary key with this keyword argument, and you can also create the index with the index equals true keyword argument. Now we're going to create two fields. The first one's going to store the name of our film, and that's going to be a string data type, so that will be varchar in the database. And we also want the name of the film to be unique because we don't want duplicates stored in the database. So we'll keep that unique constraint there, and we can get rid of the index because we don't need that. Now the other field in our data was the director field, as you can see here. So we're going to copy that, and into our model we will create a director field here, and it's going to be a string field. And this string field doesn't need any unique constraints or indexes or anything like that, so this is perfectly fine. That's all we need for our model. So that's the basic setup of the model and indeed the database objects as well that we're going to use. So the next step is actually to create the database. As you can see on the file system, we don't have a file with this name, SQLapp.db. That's what we're going to create, but how do we do it? Now the simplest way of doing this is documented in the FastAPI documentation. If you go to the sidebar here and we can scroll down to the main FastAPI app, we can skip Pydantic because we're not using JSON API responses. We can simply go to this section here for creating the database tables. And this is a simple line of code that we can add. models.base.metadata.createAll, and we bind that to the engine, and we put that in our main.py file. So let's paste that in to the main.py file containing our FastAPI roots. Just above the app object, I'm going to paste that in there, and we need to do a couple of imports here. So from the current directory, we'll import the models, and we're also going to import the engine as well as the session local class from our database.py file. So from the database module, we import session local and the engine. So this line of code is going to create the database tables if they don't already exist when you start up the server. But I will add a comment here. You would normally want to use migrations to do this and to properly manage your database tables and manage any changes to those tables. Now migrations are built into Django using the Django ORM, but you can use migrations with SQLAlchemy using a library such as 𝗬𝗵𝗽𝗶, which I will link to in the description. But this is a simplistic way that's going to get us up and running for this tutorial, so we'll use that for now. So what I'm going to do now is start the 𝗬𝗵𝗽𝗶 server, and hopefully we'll see this SQLapp.db file being created. So let's run the server here, and we should now see, as you can here, the SQLapp.db file, and using the Visual Studio Code SQLite extension, we can open this database and hopefully we'll see a film table within it. So if we extend this, you see we've got a films table with 3 columns, ID, which is an integer, and 2 varchar columns, name and director. And of course, these correspond to the columns that we set up in our models.py file for the SQLAlchemy model. So that's our setup done. What we now want to do is use the database and actually get objects from it when our FastAPI root is called. So how do we do that? Now first of all, let's quickly explain the session local class. We want to use that to actually create a session each time a request comes to our endpoint. We're going to create a database session, do our query, get the film objects from the database, and then we'll return those to the front end. So what we're going to do is inject a database dependency into our FastAPI function. This is the function here, it's called movie_list. We're going to use a dependency injection mechanism that's built into FastAPI to inject a database object. So let's see what I mean by that, but first I'm going to format these parameters so that we can read this a little bit better when we start adding more. Save that and we'll go back to the documentation. So just underneath the creation of the tables, we've got a dependency section. So as it says here, we need to have an independent database session or a connection for every request. And we use the same session through all of that request, and then we close it once the request is finished. When another user comes in, or even the same user with the next request, that will create another session, a new one in the database. So what FastAPI recommends that we do is we create a dependency that yields this session local object that you can then use to do your queries. So let's see how we achieve that by copying this code here. This is the dependency called getDB. So we're going to paste that into our main.py file just below the templates. Let's paste that in there. And basically this instantiates the session local class, and that gives us a DB object. We try and yield that DB object to the caller, and within this dependency we finally close this session at the end of the processing. So this is our dependency. How do we actually inject that into our FastAPI function? Let's go back to the documentation, and underneath this dependency you can see that we have some functions here, and we're injecting the database session here with this line here. So let's copy this just now and we'll put that into our function as an argument. So database is an instance of session, and we set that equal to a dependency on the getDB function. Now we need to import this depends object from FastAPI, so we can do that at the top. We import depends, and we also need to import the session from SQLAlchemy. So I'm going to paste that import at the top here from SQLAlchemy.orm import session. So we can save that now. And now within our function, we now have access to this database session, and then we can query the underlying database to get film objects or any other objects you might have in your tables. So what I'm going to do for now is we're going to comment out, or rather we're going to delete the films that we've got here, and instead of hard coding that list, we're now going to create a database query using this DB object that we've got now injected as a dependency. Now SQLAlchemy sessions have this query function that you can use, and we pass a model to that, and it's going to be the film model that we created in the models.py file. So we're querying over that table, and we can just say .all here to grab all of the records in that table. So that should hopefully get all the records. If we print those out, we should be able to see them in the terminal. Now of course we've just created this database, there are no records in the table, so we should see nothing here. If we refresh the page on our front end, we now see that there's nothing in this table, and the terminal shows an empty list. That is the print statement on line 34 here. And what we actually need here is a mechanism for populating our database. So we're going to use something called a startup event, and startup events allow you to perform processing before your application starts in FastAPI. So let's go to the documentation quickly and we can see what a startup event is. Now this is under the advanced user guide on the docs. If you scroll down, you should see this startup events somewhere here, events, startup, and you can also have shutdown events as well, which happen when your server is shutting down. And as the documentation says, you can define event handles, which are just Python functions that can be executed before or after your application has started or stopped. So to do this, we use a decorator. It's the app.onEvent decorator. So let's paste that into the main.py file. We'll do that below the dependency here. Now this is beginning to get a bit unwieldy, this file. You would maybe want to break this out into different modules, but for now we're just going to put everything in this file, and let's define the function, and it's going to be called startup populate DB. So the purpose of this function is to populate the database when we start our FastAPI application. So what we're going to do within here is get an instance of this session local. Basically we're creating a database session here, and then we're going to get the number of films that exist in the database, and we can use a query to do that, and it's going to be the query over the film model. And we used the .all method earlier. We're now going to use the .count method to return a number representing the number of records in that table, and we're then going to do an if statement, and we're going to check whether the number of films is equal to 0, and in the case that it is equal to 0, we want to then populate the database with some new records. So we're going to create 6 films in the database. I'm going to paste this code here. It's a list of 6 films, and we can iterate over these films. So for film and films, and for each film we can add to the database session an instance of our film model. So models.film, and we can unpack the keys in the dictionary for each of the films we're iterating over by using this syntax here. So we're adding to the database session a film object for all of the films in this list of dictionaries, and then finally we want to call the database.commit function. This will commit our new changes to the underlying database. So we should then see in this block of code that we have created 6 objects, 6 rows in our database table. Now in the case where the number of films is more than 0, it's not equal to 0, we're just going to print this number of films already in the database statement to the terminal when the application starts. So this is only going to add these films if the number of films is equal to 0. So if we already have films, nothing's going to happen except this terminal print statement. So what we can do now, if we stop the server and reload, we should see that there are 6 films already in the database, and that's because when we save this particular code, what's happened is 𝗬𝗵𝗽𝗶𝗹 has reloaded and then it's input the 6 films, and when I manually stop and start, that has already got the 6 films in the database. So that's why we see this line here. So now if we go to the front end again, we should refresh this page and we actually get the 6 films that are now in our database. And if we inspect the FastAPI function at the bottom of main.py, this is actually coming from line 53 where we query the films database table. You can see the print statement of these film objects here. So this is now being driven by a database, which is arguably the way most applications would do it. We don't want to be hard coding data. We want it to come from a reliable database store. So that's all working fine. We want to now demonstrate how to use pagination in this view and paginate our database records. So we want to pass the page in the URL. So what we can do in our URL, for example, is we could define a URL parameter, page equals 1, page equals 2, and so on. So we can do that, and then we can use that page, extract it in our FastAPI function, and then use that to get the correct set of records from the database. So let's see how we can do that. If we go back to our function here, we're going to define another argument to this function, and it's going to be an integer which defaults to 1. Now URL query parameters are accepted as arguments here. This will try and match an argument here in the URL called page, and if it finds that, it will use the value, otherwise it will use the default of 1. And I want to add that page to the context here, so we'll add another key value to our context dictionary. So now that we have that, we can access the page in our templates. What we want to do when we hit load more is we want to increment this page. Now by default it's 1, so when we hit load more we want to get the next page of data, so the page would then be 2. So we're going to attach the page as a URL parameter to our button. So let's go to our template now, and it's this index.html template, and this is the hx get request. It's here that we want to attach the page parameter, and we're going to use the current page value and we're going to increment that by 1 as so. So if we save that and refresh the page, we should see when we hit load more, we are getting more records, but it's not actually using the page data yet, but you can see that it's getting the page here. But the problem is the actual content here in the index.html is never replaced. We need to move this button into our table because this is the partial that HTMX deals with. If we don't replace the button, then it'll always be page equals 2, if that makes sense. So to demonstrate what I mean, let's cut this button out of this template here, and we're going to move that into the table.html. So we have a for loop in here that iterates over all of the films in the context. What we're going to do below that is we're going to paste this button and we're going to place it within a table row. So we'll place a table row around this button, and we can close that off here like that. And we want this button to be in a TD, and the call span should be 2. There's 2 columns in the table on the front end, so we want the call span to be 2 here. So let's fix the indentation of this button here, and if we now refresh the page, we have the button at the center of this table. Its call span is 2, so that spans the 2 columns. And if we hit load more, we're not getting the effect we want at the moment, but this is what we're building towards. So what we want to do, if we refresh the page, when we hit this button, we want to replace the button, the table row containing the button, with the new content. And this new content is returned in this partial, so we get a new set of films based on the page, as well as the new table row at the end containing the button to load more data. So this button at the end is continually going to be replaced with the new data coming from this for loop, as well as another button placed at the end. So to do that, we need to change the hx target. What we want to replace is the closest table row. So that's going to be the parent table row for this button. So what we can do is use the closest table row here, closest tr, and the hx swap mechanism, we want to swap the outer HTML. And that's because we want to replace this table row containing our button with all of the new content coming back from this partial. So if we save that and go back to the page, when we now hit this button, we see that we're getting more rows in the table and the new buttons placed at the end, and that pattern can continue indefinitely. So the final step in this tutorial, we want to actually paginate the database data that's coming from SQLAlchemy. Now to do this, we're going to go back to our FastAPI function in main.py. Let's get rid of the print statement here. And what we're going to do to this films query is we're going to amend this. We don't want to return all of the records, we now want to paginate the data. Now I'm going to create 2 variables to help us do this. The first variable will be called n, and this is going to determine the number of objects per page. And we want to set this to 2 for demonstration purposes. And rather than returning all of the records, we can limit that to the n records that we want. So if we save that and go back to the page, instead of loading 6, we now get 2. But the problem is it's always the same two that are loaded, so we also need to add an offset that is based on the page number. You can see the page number coming in here, it's incrementing from 1 to 2 to 3. So we need to set an offset based on this n here and based on the page. So to do that, let's create an offset variable, and we're going to do a little bit of maths to calculate what this should be. It should be the current page number minus 1, and we multiply that by n to get the offset that we want. And when we have that, we can then add an offset to this call here. So it's going to be .offset, and we'll pass that calculated value there. And then once we have the offset, we'll limit it to n results after that. So let's see what happens now on our table in the front end. We start with 2 records, then we hit load more and we get the correct offset for the next 2 records, and we load the next 2 records. And this can keep happening until we have 6 records, at which point we're no longer going to get more records because the offset is actually greater than the number of records in the table. So just to demonstrate why this works, when we get the first 2 records, the page number is 1 here, so 1 minus 1 will be 0, so the offset is going to be 0 in this case. So we start from the very first row in the database table. Then when we hit the button here, it's going to load the next 2 records, and you can see here the page is now equal to 2. 2 minus 1 is 1, and then we multiply that by our number per page, which is 2. 1 times 2 is 2, so our offset will be 2. So this will basically start after the first 2 records in the database table. The offset will be from record 3, and we'll get the next 2 records. So I hope that makes sense. That's all we want to cover in this video. We've learned how to add a database to our FastAPI application. We've learned how to do SQLAlchemy models to represent our data, and we've learned how to inject dependencies into our FastAPI functions, as well as how to do startup actions using the app.onEvent decorator. And finally, we've learned how to perform basic queries using SQLAlchemy, such as getting all of the objects, getting a count of the number of objects, and also how to do offsets and limits. And this is all integrated with HTMX on the front end. So hopefully you've learned something about how to use FastAPI and databases with the HTMX library. If you've enjoyed this video, please like and subscribe. Check us out on Twitter, and we'll see you in a future video.